The last example we want to look at when talking about an introduction to functions is writing an equation. So we've worked with just the input-output table, we've worked with graphing the input-output table. Now let's work with writing an equation and then creating an input-output table and graphing. This example says as you dive deeper and deeper into the ocean, the pressure of the water on your body steadily increases. The pressure at the surface of the water is 14.7 pounds per square inch psi's. The pressure increases at a rate of 0.445 psi's for each foot you descend. Represent the pressure P as a function of the depth D for every 20 feet you descend until you reach a depth of 120 feet. And then notice here it wants us to write an equation, create an input-output table, and make a line graph of the function. So let's start by writing an equation. If we kind of talk about a verbal model, keep in mind we want to represent our pressure. So let's start with that. Oops, sorry about that. Our pressure, okay, at any depth is going to be equal to what our pressure is at the surface. It tells us right here. So the pressure at the surface so we're going to have our pressure at the surface, and then it's going to increase. So when we say increase, we know that's addition, at a rate of 0.445 psi's for each foot you descend. Okay, so it's going to increase, and I apologize for the control shift. I'm not able to get rid of that, I don't believe. No, it won't let me. Okay, so the pressure at the surface is going to increase at our rate times our depth. Okay, so our pressure that the pressure that we're gonna feel as we keep diving further and further down is gonna be equal to whatever our pressure is at the surface, and then it's gonna increase. So it's gonna increase by this rate for our depth. Okay, if we want to change this now into a algebraic model, we could say our pressure P is going to equal what our pressure is at the surface. Well, the pressure at the surface is 14.7 psi, plus our rate, it says right here what our rate is, 0.445 times our depth, okay, for each foot you descend. Our depth we want to represent with a D. Okay, so that would be an equation we could write for this function. Again, our starting pressure right here says as you dive deeper and deeper in the ocean, the pressure steadily increases. We're starting at 14.7, and then it's increasing by this rate. So that's our equation. Now we can take this equation and we can write an input-output table. Well, let's see if I can get it to copy here. I can't. That's right. I'll just rewrite it. Okay, so pressure equals 14.7 plus 0.445 times D. So again, if we create our input-output table, and I'll do a horizontal input-output table right now. D is our independent variable. It's like our X. It's what we're going to input. And we want to figure out what our pressure would be. Well, if you look at our question here, obviously if we're at the surface of the water, the pressure on us is this 14.7. So we haven't dove into the water at all, so our pressure is 0. And then notice we're going to go until we reach a depth of 120 feet. So our pressure is going to go from 0 to 120 feet. So again, input-output tables, you can pick whatever inputs you want. So I'm going to use 0, 20, 40, 60, 80, 100, and then I'm going to stop at 120 feet. Okay? So all we're going to do now is we're going to input our independent variable, our D, We're going to substitute that in and solve the equation. When we do that, these are the values we get out. We put 0 in for D, obviously that cancels, we're left with 14.7. If we put 20 in for D, we get 23.6. 40 is 32.5 psi's of pressure. 60 is 41.4. 80 is 50.3. 100 is 59.2. And 120 is 68.1. Okay? So what we've done is we've wrote our equation, we used our domain and came up with an input-output table, and then finally we're able to graph it. Okay? So we're kind of putting it all together now. We're given a problem, we're writing an equation, we're creating an input-output table, and now we're graphing. So let's put depth here at the bottom and our pressure on the side. So remember from our input-output table, we just sent 0 to 120. So maybe we can go 20, 40, I wonder, 10, 20, 30, 40, 50, 60, 70, 80. Yeah, we can do that. Never mind. Let's try this again. Oops. Let's go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, and 120. And then our pressure is going to go from 14.7 to 68.1. So let's go along the sides 10, 20, 30, 40, 50, 60, 70, 80. That should be plenty. Okay? So if we plot our points now, our first point was 0, 14.7. So you just kind of approximate where 14.7 would be. Then 20, we went to 23.6. That's going to be right in here. 40 is 32.5. Here's 30, 32.5 will be there. 60 is 41.4. So somewhere around there. 80 is 50.3. 100 is 59.2. And 120 is 68.1. Again, notice that these points, oops, it's not going to let me draw that line. I'll try to freehand it. These points all lie on a line that I'm not going to be able to draw, so I hope you have better luck than me. Oh, it's close. Imagine those are all lying on the points. But we don't continue our line any further, and we don't put arrows at the end because, again, our domain from our original question says the pressure, our zero depth is at the surface all the way down to 120. So we can see from this graph how much the pressure increases on our body the deeper we dive. Okay? So again, their functions help us show the relationship between numbers. It's important to remember that for every input there's exactly one output, and within a function we can create an input-output table and graph our data.